Okay, hi, Ruslan. Ruslan is right?
Hi, Dan. Yes, exactly correct. It's Ruslan.
Ruslan, perfect. What was your first computer?
It was Yamaha MS6. I listened to your podcast and I had to figure out what was
okay.
it.
And I hope I can surprise you with the question.
I hope too, yeah. So I didn't listen everything. So, just basic structure to understand.
So then I had, of course, modify the question for you. What was your first cloud? It would be a better question, right?
What is it was cloud? Okay, look, it was a known one, but it was, it's not widely known. But they had very good solution in terms of scaling virtual machines on the fly. So you can add more resources to the same virtual machine without reboot. Mm-hmm. Even today, like not many cloud vendors offer the same solution. It enabled me to do some experiments with Java, with elasticity. So I will say at that time, the idea to improve Java and make it more elastic was born.
Okay, perfect. So back to Yamaha. I never heard about Yamaha. So what is it?
So it's a normal computer. It was not my personal computer. Let's say I got it in the school classroom. Mm-hmm. Yeah. Actually, I did not have my personal computer till 20, let's say. Yeah. So it sounds maybe crazy, but it's reality.
1920s or your age of 20?
My age of 20.
When was it roughly? When was it roughly? You don't be precise. No, roughly.
It's like so. Let's say 20. So I can tell you exact date. Exact year. It was 2001. So 2001. I was able to get out of the high school and I got my first job. I collected a little bit money and then I was able to buy a computer.
Cool. Which one?
It was Pentium, I believe, something like.
Okay, of course. 2001 was Pentium 3, even more. What I had in 2001, I had a Xeon, double CPU. This is what I had, I remember. And it had some problems with on a motherboard in Linux. So there were some kernel issues with two processor CPUs. So this was between 2001 and 2003 in this range. Okay, what the first thing you did with Yamaha? You played with that or you programmed hex immediately something in assembler or what you did with that?
Look, of course we were learning programming language and the programming language was basic.
Of course.
So I don't know, I like that language, so I got it very quickly. I became probably one of the most advanced students.
Cool. Why? What you built with that? I
don't know, I just got it so quickly, like I did faster than anyone else. Cool. And let's say in several lessons, teacher put me in front of the main computer and I was uploading games to computers of other guys.
Cool. So you were the true hacker. So one question. So now interview question to you. What is go sup?
What is what?
Go sup, command in BASIC.
Goes up. So very good.
Hey, you see? I have to admit this is one of the view commands which I remember. And with that, it was my first pattern. So I was proud that I know go sup. So now, after 30 years, I can reuse it again. This is like go to, but it comes back.
Okay.
So go to goes and go sup comes back, right? And if I saw in BASIC go to, I always said, you are stupid. You have to use go sup. It says not modular. There was another term. I said it comes back and is better or whatever, right? Nice. Yeah. This was the beginning of methods. Okay, exactly. What you did with the computer? You wrote which program or what you did? Which something which is noteworthy.
Look, at that age, I was still young. Probably it was 12, 13. So, and I had very limited access to the classroom.
Okay.
But later, when I went to high school,
where was it? Was it in which city or what? Where was it?
It was in my city in Ukraine. I was born in Ukraine.
Ukraine. Okay.
Zhytomyr.
Okay.
Yeah, Zhytomyr. Yeah.
And at that time, they had already computers. It's remarkable.
Yeah, actually it was a surprise because our school bought very new Yamaha computers. Yeah. At that time it was, something unreal, in ex-USSR, it was very hard to get computers.
Yeah, of course.
Yeah, but for some reason, I don't know how they did it, but my teacher, found the solution, and they got the full class of very nice new computers. It was very exciting for all of us. Yeah. And then let's say, I participated actually in some competition in our region. I got probably like something in first 10 place. I don't remember exactly, probably it was 9.
Wow.
But the problem was, look, I could probably win even first, make a first place, but the problem was my program was calculating too long, like, and I had
it was
concern,
not efficient enough, right? So your algorithm was not right.
No, I was concerned maybe like there is some end loop, endless loop maybe does not work, like, so I didn't have enough time to wait, let's say, right?
Okay.
And then later, like, so I did some tricks, to get the result, but get it faster, but it got result during specific range. Out of that range, it did not work well.
Mm-hmm.
So, but after I figured out what was the right answer, so the program that won, that program was calculating too long as well.
Okay.
So if I, follow my initial algorithm, probably I will be able to get better place at that competition. Yeah, but I learned it, from this. So I need to be patient. I need to double check, initial idea. If it looks not correct, maybe it's not the truth. Maybe you need to, take a look from another angle.
Yeah. So helpful experience. And by the way, you enjoyed programming from day one, or you?
Yes, I do enjoy this from day one. I don't know,
and why? Were you fascinated by the machine itself, or by hardware, or by programming, or by the feedback, or what? Why you like that?
In different period of time, I like different things, but definitely the most important, what motivates me to
back then. Now it doesn't matter, but back then, what motivated you back then?
Look, I'm still doing cool stuff during the weekends. Like, I'm waiting for weekends to program.
Okay.
Why I like it? Because I like to solve complex problems. So if I can solve it, I get good adrenaline, portion of adrenaline. Yeah. So I can do it, like, it works. So I just enjoy the process.
Yeah.
And I do like solve complex problems.
Okay. This can be me later. At the beginning, I just liked the hardware, and I wanted to do something useful with it, but I had no idea what to do, It's like, this is cool, I would like to use it, but I have no idea what to do with a computer, This was... and then, now I enjoy solving problems. Back then, no chance. Okay, cool. And why you participate in the competition? You just,
Yeah, because I was uploading games to all students, so the teacher said, like, okay, you're one of the best, go and show what you can do. Like, that was the reason.
And we were 14 roundabout?
Yeah, something like this, like, roughly 14. But later I went to high school and we got access to another kind of computers, actually.
Kawasaki. or Honda.
BMW.
Yeah, exactly. I have to look it up, the Yamaha. I never heard about this. The Yamaha is doing computers back then.
Yeah, like, so MSX series, take a look.
Okay, I will do. Really.
Yeah. So, and it was IBM computer and PL language. So I was programming PL language.
PL1.
PL1, yes.
Yeah.
I don't remember anything now, honestly, but I built programs on this, and I built programs for students to do some work, like testing.
Mm-hmm.
So, and then I learned Delphi.
Okay.
The Delphi.
Yeah, Delphi was nice.
So because it was easy,
I wanted to learn actually Delphi, but I stopped with Turbo Pascal. So I started with Turbo Pascal, and they will talk me, the next step is going to be Delphi, and this is object-oriented. I was so fascinated what means object-oriented, but they say, hey, no one could explain you what it means, so that you have to do Delphi, but I never had time to do it. Okay.
Okay, very interesting. By the way, in my case, I skipped Pascal. I learned some basic stuff, but I didn't write programs. Mm-hmm. On this, like, I don't know, I just jumped directly to Delphi, and it looked more powerful at the time. We had like more UI elements and easy to program, let's say, for beginners.
Okay.
So I started to to learn Delphi.
What you did with PL1 and what you did with Delphi. So was there anything mentionable with PL1?
So with PL1, for example, when you have to do like test at mathematical lesson.
Okay.
So I built a program for this test for mathematics, let's say. Students were using my program to pass exams, let's say.
Oh. So then you then you were wealthy, you know. It's like, okay, would you like to pass, you know? Upload a game.
At that time, I did not have access to, you know, like to the system when they test the students. So I had only access to at the beginning when
this
the program.
Is how you develop your own first remote payment system, right? In the cloud. This would be cool. Yeah. Okay. PL1. I've worked with someone. He told me that PL1 stands for Programming Language 1, actually.
Something like this.
Yeah, this is incredible. Okay, Delphi. What you did with Delphi?
With Delphi, I did different things, but the most remarkable one, I built solution to calculate location of a point based on signals received into other points. So if you have 2 points and you receive the signal, so you can calculate location of the point on the Earth, let's say. So
like GPS? Triangulation?
Like GPS, yeah, like, yes, exactly, like triangulation, yeah.
Okay.
Exactly. So,
and why you did it? Just for fun, or was it assignment? Or
look, I was learning, let's say, special course which is called Devices for Geophysical Monitoring.
Okay.
And they register, sensor register can register different signals.
Okay.
And sometimes you can say, okay, this is signal from that direction, and this is the distance, like, you know, for that signal. And if you have like several points like this, or at least 2, you can calculate like location.
But you need a really good timing, right? So very exact timing.
You need exactly, like very, very. But we are talking about electromagnetic signals, for example, right? Yeah. And they're traveling very fast, so it's very precise methods to calculate location. And my teacher did very good job in mathematics, so he created some special algorithm because it's not super easy, let's say, to calculate on the Earth, because Earth is not round; it's more, you know, like some ellipse. So,
potato.
Exactly. You need to put specific formulas to calculate it correctly. You know.
Hey,
go ahead.
At the workshops in Munich Airport, there was a woman, and I have a chat with her. So she was developer, and he learned something. I don't know, back then microservices, Java, and back then I explained something with JavaScript very briefly, and I say JavaScript is terrible with that, with calculations. And she told me I do it with JavaScript all the time. And I asked her, what you are actually doing? And she told me she built with JavaScript. I forgot actually the the name for that. But every area on Earth, if you build a map, has a different algorithm to calculate, you know, the areas, because, you know, Himalayas is a mountain, and if you have a map, it is flat, but mountain is high. So there is a different algorithm applied for Himalayas than for Switzerland or Netherlands, right? Because Netherlands is flat, it's 1-to-1. Yeah. And she said, and I have to do it for Greenland because no one did it for Greenland, and she did it. And I say, you are amazing. So why you are sitting in my course, you know? I mean, what I'm just doing, deleting code, and you can nothing learn from me. It's like, yeah, but she need now to build a microservice in the backend. This was incredible. And she was, what I learned, that Greenland belongs to another country, I think Netherlands. And she spent some time in Greenland to learn, you know, and she programmed the algorithms and came back. So this was actually the story I learned, that every country or area on Earth, they have a different algorithms. I forgot the name for them. So geospatial algorithms to calculate the areas. Because if you look, you know, from above at the map, you know, the Mount Everest is like a triangle, we'll say. But if you would look from above, it'd be not a point or smaller than it actually is. So this was interesting. So,
exactly.
Yeah.
Yeah, exactly. So you need to take into account all these points when you calculate. So that was my experience with Delphi, and I did good job. My program was accepted by the commission. I mean, like.
But it was too slow, I suspect, right?
It was okay.
No,
it was okay.
Now it was faster.
It was faster. It was faster.
Cool. And this was like assignment in high school, like, you know, a final exam or something like this.
Exactly. Yes, that was the final exam.
Wow.
That was the final exam. And for this exam, one big guy came specifically to take a look at this program.
Okay.
And listen to what I say. Like, so.
There came a guy to watch you at the final exam. What I wanted to tell you is, it is actually hard. I mean, was it a special school? for talented people? I mean, you cannot expect
a
students
special
to hack.
school. Actually, we had only 12
school.
people that year in whole Ukraine who were learning these devices for geophysical monitoring. I will say, like, I was lucky to get to this group of people.
Wow.
Like, it was really accidentally, so I didn't know. I didn't pay money anyone.
Okay. No.
Okay.
I didn't suspect it.
I will say
anything.
Nothing because at that time it was, let's keep the topic.
Yeah.
Something like this. Something like
still communist era, right? Back then or not?
So the guy that came, they were looking for people who can do programming for their organization. Because they had a lot of computers, but nobody knew like how to program these computers.
This was like me back then.
Exactly. And
I had a computer, I had no idea what to do with it.
Okay. Figure out what was the computers like and what was the reason why he came. But he came again to take a look at me, and after he bought me, because when you finish school, you have some kind of so this school can send you to one place or to another place, you cannot choose. They should send you to a specific place, and you have to work there. And this guy said, we need Ruslan and one more guy from this course, so send them to us. And I was thinking it's disaster from the beginning, honestly, because they sent me in the middle of nowhere in the forest. It's like, living in the middle of. No, it was actually near Zhytomyr.
Was it Siberia or was it forest or not?
It was about 90 kilometers from Zhytomyr, but I didn't have a car, and the road was terrible, honestly, to that place. I can tell you why it was a forest, because it was very strategical point of ex-USSR. So now it's not a secret anymore. It's not a secret place, but at the time, in ex-USSR, it was a closed city, so people cannot enter there without special permission.
Okay. Wow. Okay. Can you tell us what name of the city was? Or is it now forbidden?
Open now. But I have no idea still.
No. Then don't tell it. Tunguska, right? You know Tunguska?
Because it had nuclear rockets, I believe, storage for nuclear rockets, yes, and also department who controls nuclear explosions around the world. So, and I came to the department, to that organization.
And how was it? Was it very sophisticated, nice, or not at all? So how to expect for such organization?
Look, it was not like James Bond, but definitely it was.
But was it nicer? Nicer buildings, or was it just usual?
Normal buildings,
everything
normal
normal
buildings. So you cannot say but you can see, there is an organization, but you cannot say what it is.
Okay.
And also, this organization does not only this, but just general geophysical monitoring. So, control earthquakes around the world, control disasters and catastrophic events, and so on. So, what happened? The organization bought a lot of Sparcs computers from Sun.
Wow.
Look, at that time, it was crazy investment because they were super expensive.
Yeah, of course.
Exactly, yeah. But they bought it because...
how big is the Sun Fires? So the big one or is a mid-range one?
They had different of them, let's say. It was about 20 computers. So I even had huge monitor from Sun connected to Spark. So, and why they bought it? Because software, which was working with special devices, was written specifically for Solaris.
Okay.
Let's say, right, and they was not able to develop the same program by themselves, so they bought a ready-to-go solution.
Yeah,
that was the reason. However, they bought a lot of computers, and many of them were sitting without any work. And they asked me if I can do something with this. I said, I will try, of course. So, and what I like about my beginning of work, let's say, adult work, that my boss told me, look. You have the goal. How you do it, I don't care.
Very good.
But you do it, and And he did not touch me at all. Like, he did not give me like extra tasks, like that might blur my focus. And so on. Of course, I did some extra minor work, but my major focus was on this. And so I decided the following. What language I can use to program this Spark? So it was C or Java.
Huh.
And Java was, exactly, so that was the beginning of Java. And Java was obvious reason to choose because we also had Pentiums in the organization.
This was then later, right? This was shown, this was like 1997 or something like this, right? I suppose.
It was already 2001.
Oh, 2001. So this was actually, this is actually interesting. This is, okay, this is almost recent times, okay? So, and the school you finished, was it a high school or university?
University, let's say university. Yeah.
Ah, okay, then I got it. But we skipped. You were in the high school, then was at university, and we are talking after university.
Look, when I say high school, I meant university.
Ah, okay, very good. Because I said this would be strange. As high school kid, doing electromagnetic device and be bought by a secret organization. This would be like a small Einstein, I would say, right?
Okay, let's say maybe a little bit different. Yet.
Okay, no problem, but it's still remarkable. Okay, and do you had a choice, or you had to go to this organization?
I could not say no. Let's say
for I would say political reasons, or because it was so cool.
Because I must do it. If I finish this university, I must follow the rules. I didn't pay for.
Okay. But this is the same in Germany right now. So you can study, at the military, or it was 20 years ago, and then after the university, they would expect you, to join the military or something, because, exactly, okay, that is normal. I thought, this was like public school. They came and say, come to us, and you had no choice but, go to this secret place. No, but that is actually cool.
So, so when I did I stop at Sparcs, I believe, right? So it was many Spark platform, and Java was obvious choice to program for this. So I started to learn Java, and I got good results. 1.3.
Okay. 1.2?
At the time, it was 1.3 already.
Oh, not bad. Okay.
So but it still was not enough information for me because internet was slow at that time. It was very limited access, like no information, how to learn. And I was struggling. But at some point, I visited an event in Kyiv, capital city of Ukraine, and I see the stand of Microsystems with Spark platforms. And I come to the stand and say like, oh, very nice computers. Like we have many of them, and guys, like saying, how it's possible? Like, they're too expensive. Like, some guys, small guys come in and say we have many computers. Yeah. I say, look, I'm working in a specific organization. We bought like many computers from you. He said, like, which one? I said, that one. He said, oh, yes, true. It's true. Yeah. Like, I say, look, I have a big problem. Like, I don't know how to program these computers. Like, help me somehow. And he said, like, wait a minute. He went to some secret room, I don't know, like, and he brought 8 CD disks fully, let's say, with full software for development for Spark platforms. Like it was studios, like ID studios, materials, documentation, examples, like collections and so on.
Yeah. JDC, probably Java Developer Connection CDs. So there were lots of them.
And it was not only Java, it was like for C, like everything related to Spark platform at specific point of time. So they uploaded everything to these disks. It was 8 CD disks. I have this artifact today still, like in memory. But it was very cool for me and very helpful. It speeded up my learning very much, let's say.
Okay, cool.
So and then I started to program on Java, and I started to build really nice, cool things. Yeah.
Can you talk about that, or is it still secret?
Yes, we can actually. No, we can. It's not a secret. An interesting point, like I started to evangelize Java inside organization. I said, like, guys, it's a very nice language. Let's learn together. Let's build stuff together. But some people told me, look, Java will die.
Yeah, of course.
I said, no way. Like, it's very nice and beautiful language. So, but they didn't follow me, honestly. Like, so I was mostly alone. but I had very strong motivation. And I started to build programs, specific program. I actually built many of them, but one of them was my favorite and changed significantly influenced my life. So that program was for collecting geophysical data from distributed international data centers in real time. For example, if event happens somewhere, like for example, earthquakes happens in Indonesia, right? You can connect to specific devices in that region or to data center in that region and request samples of data, like for a specific period of time. And then you can do analysis what exactly happened. Like, so you can say, okay, it's an earthquake, or it's an airplane crash, or it's explosion. Where did it happen? Is it like on the ground or underground? Like, and what is the magnitude? Like how it can affect people around?
Have you just collected the data, or did you to analyze the data as well?
I did the full set, actually. I did the full set. It was long-term work, honestly. But I got approval from this guy, actually, who came from me, who bought me in school.
Was it a nice guy who came to you, or was it
He was... I appreciate him very much because he... how to say, like, when people judge correctly. Like,
So he saw potential in you, right?
He saw potential in me. He gave people opportunities. You know, he asked if you don't deliver. You know, he asked, where are the results? You know, like, and if no results, get the penalty. But in general, he always gave opportunities for people, and it's very helpful. So at some point, I came to him and I said, "Oh, actually, what happened? My boss, I came with idea. I got the idea. Like, you know, after working 2 years, I got an idea. Like, look, we can automate all this stuff and make the life simpler." And I came to my boss, direct boss, and said, like, let's build this stuff. He said, no, I don't like it. Build better program for me that I have to build my idea, let's say. So I had a conflict with my boss at that time. And I went directly to that big guy and said, like, look, I know our organization has a problem. I can solve this problem. For that, I need like six people from different departments, and nobody touched me during the next 6 months.
Wow.
And surprisingly, he accepted this.
But your boss, your direct boss, was not happy, right?
Absolutely. After this, our relations was broken.
So what I see, you attended a lot of soft skill courses before that, right?
What do you mean soft skill course? I don't know what this means.
Soft skills courses, politics and how to, choose the right words and. This was just joke. I know. This was just a joke,
It was straightforward. It was a conflict, honestly. Like, so he was not happy, and he, even more like he understood like his boss. Actually, it was his boss gave tasks directly to me. So, but anyway, like the problem was really complex, and during the time, my direct boss, he understood it's okay that I'm working on this. It's good for everyone. And so what we built a system that requests data from different international, again, data centers. Then it converts to a specific format, this data, right? Then it does automatic calculation. So it calculates parameters, put metrics, marks on the signals. And then what was very interesting solution. So because, look, we had Sparcs in the server room, right? But all operators, people, was using Pentium. And how you can use information, programs from one to another one, only Java, right? But even Java was not a good solution for that time for Pentiums. I don't remember exactly the reason. So I built solution based on X11. It means you run stuff on the Spark, but you export X11 to X window to Pentium. And it became very powerful solution because with slow Pentium, you can use great power of Spark platforms, and all calculation happens on the server side. So you can do stuff remotely. And I built some kind of combination of, AJAX. Then it was running inside the GlassFish server. And then I was using.
Why you use GlassFish and you didn't start it, with your own stuff? I mean, you could write everything from scratch. So why you came the idea to use GlassFish or Java EE?
Because I was using web services.
Okay.
Yeah.
Metro.
So, yeah.
Back then, I guess.
Micro web
No,
services.
Metro.
They were micro.
No, Metro. You know, there was the Metro, METRO web services on GlassFish back then. This was like, I think this was the name of the framework. It was Metro, I think it was Sun Microsystems Metro services, and this was the name of the framework on GlassFish. Doesn't matter. It's that anyway. Okay.
Okay. Don't remember honestly. Like,
okay. But because of web services, you use GlassFish. Okay. Okay.
Yeah. So yeah, that was the solution actually, and we wrote documentation for this. We did a very good testing, and it was implemented. Replaced all systems. So and people were using this like 10 years after I left the company. So they did not even update this. So it worked. It worked very well. What stopped working is Firefox. Actually, yeah, because I built rich web UI based on AJAX at that time. Actually. So, but of course, it was built especially for version 1.0 Firefox, I believe. And during some period of time, it stopped working. Yeah, but yeah, it was replaced by another.
But what you did it? I mean, just to understand. So you wrote a software which ran on GlassFish and exported X11 protocol to via Comet, I guess, right? Back then, probably. This was prior WebSocket, so you had some kind of socket. And you wrote an AJAX solution, which interpreted you created X11 viewer in browser, or you polled the server and generated JPEGs or whatever, or PNGs. How it worked? You actually implemented the X11 protocol in browser, or you polled the server and received, screen updates?
Yeah. So how it works? For example, you open browser and then you have map with stations on this map, and maybe even with event where the event happened. Yeah. So you have some basic information. Then you put lasso around this event, and you can choose stations from which you want to collect data. Right? So all of this was inside browser, and it was with help of AJAX. So this initial management and request was done with help of AJAX. Then you request the data. Data comes to GlassFish. GlassFish runs web services. This web services starts to request data from international data centers. Then data centers send. It's like it can be synchronous or asynchronous data delivery. So depending on the sensors. So some data was coming synchronously, some data was coming asynchronously. So asynchronous data was coming again to some service at GlassFish. It was converting to same format for the processing. Yeah, and then I mounted this data to program which was running inside Spark. Right, and I configured the program on the Spark. I run the program on the Spark, and as I say, export display to the computer with this IP address. So an IP address was the IP address of operator who was working with the browser. So the operator had to use browser and specific program.
So you have two channels. Okay, X11. Okay.
Yeah, two channels. Exactly.
Okay. I'm asking because I was involved in a project 2003 with JBoss, and what we did similar thing with applets. So we are able in applet, to view the system. Right. But this was not like X11 protocol. It's more like a custom protocol for one of my clients. And the student built actually the viewer, and this was amazing. You can zoom in, zoom out. Back then, it was crazy. Okay, cool. Wow, there were one of the GlassFish 2, was it? 2003, I guess. What you used. Because the 3 came around 2008 or something like this.
Yeah, but it was built a little bit later. Let's say, so 2008, I finished working at that organization, but I started, let's say, 2 years before, 2006. Maybe this project started 2006, 2005, something like this. Yeah. GlassFish, I remember number 3 for some reason. I don't know. Yeah, but maybe I started from 2 and then upgraded to 3. Yeah, maybe like this. Yeah.
Okay.
Yeah, that was very useful one solution.
Why you stopped at the organization? Stopped working with them?
Oh, very interesting. Look, the point came after I built the system, and I know that the organization paid like $5 million to build the same software. They paid for another organization, and they failed, actually, completely failed. And what happened? They accepted my software instead of that software, but I got like $20 bonus.
Okay. Yeah.
So like I said, okay, like if no money for me here, and I got fun, like it's still fine, sitting in the middle of the forest, right? Yeah, but I said, okay, like if no money, maybe I can get power. Like I came to the guy, I said, like, look, I do.
So go away. I would like to have your place right now, right? Give me your money or go away.
I asked it. Look what I asked it. I said, like, make me the main guy of the IT department in the organization.
Yeah. Yeah. So at least straightforward. That's the solution.
Exactly. Because everything was not interesting anymore for me. Like, look, I got very high. Yeah. I built this complex system. Why I wanted to become the guy of the department, because I have the goal to teach other people, to learn programming and do more cool stuff.
Research or whatever. Of course, you can play with things. You can investigate and be sure. Yeah.
Exactly, because what happened? The guy from science department became more advanced than guys from IT department.
Okay.
So, and I wanted to solve the problem.
Yeah. And I guess your boss said no, right?
The boss said no because probably it was big already.
That's because you skip him because you ask your super boss. So
no, I came to super boss.
Okay.
I came to super boss and asked make me. Super boss said like, no, I cannot. Like, so
why not?
Stay.
Why he said not?
Maybe it was busy already.
Okay. It's always interesting because I never worked for a company. I also was freelancer, and it's always nice to see how the politics are working. For me, it's funny almost, because if you look from outside, it's funny. If you are inside, it's not that funny, right?
Look, it was not commercial organization; it was government organization, so it works even differently comparing to.
I already had the conversation with someone, and I think I told it on a podcast. So we had a task force, and it was really sophisticated, and I worked with internal people, and the internal people were really involved, and we solved the problem, right? And then the internal guys were called to the super boss, and the super boss gave them as a reward a small toy, So I don't know even whether it was 20 euros, and one guy said, "I'm quitting." This was very similar to you. Completely understandable for me. I mean, the worth of the work they did. It was millions, and there should be a way in company to reward such work, because it was not usual what they did, and they worked overtime, and they were really passionate, and I say this is a crazy why this was a pity. Okay,
exactly.
And how you quit, and what happened afterwards after secret organization? Is the name of the secret organization secret, or is it?
No, now it's not a secret. So it was Department of National Space Agency of Ukraine, Department of Special Monitoring, National Data Center, Geophysical National Data Center of Ukraine.
Okay.
It's a really long name, to be honest.
No, but interesting name. Interesting name. And what we did afterwards? So you had a solution to that?
Look, it was not easy to quit, honestly, because usually such organizations, you are married forever. Yeah, but actually, interesting point. I wrote a program for another organization. It's Antarctic Ukrainian station.
Wow.
So we were Ukraine is one of the not many countries that have station in Antarctica.
Okay.
And I had a ticket to Antarctica.
Okay.
At the year I queued the organization, so it was competition. Like only 12 people go to every year to Antarctica, and they sit there the whole year. And then they come back after 1 year. So I had a ticket already there. I won the competition, but some health issue happened.
Okay.
Yeah, and I just wasn't able physically to go.
Okay.
There. And I decided, okay, like if it happens, maybe it's a signal. Maybe I need to quit. And that health issue helped me to escape the organization.
Oh, very good. Not very good. I mean, a very good strategy that you could escape. So.
Look, that was the situation. Like in reality, I got sick, but from other side, like it was the reason strong reason to stop working in the organization, because I need like special treatment.
Okay. Okay. And afterwards, so you got the treatment?
Yeah, and just like why I decided to keep like in parallel, I was trying to understand how strong I am what can I do? Can I make money actually with programming now? And in parallel, I was trying to figure out like maybe I can do some paid work. And I found a project that nobody was able to build it, solve it. And I said like, okay, I will do it. So it was interesting one. I did it. I earned, let's say in a month, more than I earned in a year in that organization.
Wow.
So yeah, after I realized, okay, like, so that's a good way probably to go.
Okay.
So maybe I need to stop working for government.
Okay.
Yeah, and I quit government. I started to work for startups, for several startups. I saw how they felt. Yes, it's true. So it was actually time when many startups started. I was building actually JavaScript side and some startups client side and some startup server side.
jQuery back then.
jQuery actually, yes, but I had my own library. I called like full AJAX. It just converted the whole web page automatically to AJAX. So you just connect the library.
Nice.
So, but anyway, jQuery I was using a lot as well, and I like the tool, this library. So yeah, like, and I started to earn normal money. Started to learn how commercial programming works.
2009, 2010. Yeah. When was it?
2018. Yeah, 2018. Yeah.
2018 was it, or 2008?
Oh, sorry, 2008.
2008 or 2010, something around that. Okay.
Yeah, exactly, 2008. Yeah, like so. But also we figure out while I was working for like a freelancer for several startups, I figure out there is a problem with infrastructure management because like, okay, when you want to deliver a new update, you need to create like stage environment, like, and I cannot create stage environment. I need to wait like system admin guy, but he doesn't want to do it like for some reason, like I depends on him what to do, like, you know, and all these things. I realized, okay, like maybe I can build something for myself to speed up my freelance work and be faster, be more efficient. And I started to build platform for my own needs.
Okay.
And actually, it helped me to earn more money faster. So I remember interesting case when one guy came to me and said, like, I want to build upload of application for uploading photos to my server. And we had no smartphones at that time, only phones with Java, right? And I was building this Java for
J2ME.
Exactly, J2ME. And I built something like Instagram people do today, and I built it in 2 weeks. I gave him prototype. My task was for prototype, and I built it for many phones. It worked well. I gave him. I got my money. Later, guy hired more people to build like, you know, production system. As I know, they were working like 3 months. They were not able even to get to my prototype level. So
but they had, in contrary to you, nicer UML diagrams, and they wrote, you know, Java doc, and they had meetings, and you and you just deliver the code, you know.
Of course, you know how it works.
And they wrote probably even some Word files, you know, some Word documents.
I'm pretty sure. So yeah, like this is how it works. And at some point, I was working for a very nice startup for analyzing market of hotels booking. I mean, like how rooms go up, down. Like very interesting one. We collected a lot of data. We built UI for this project. But during the night, I was working on my project, on my idea. So literally, like I had like 2 works. During the day I was working for a company, during the night for my own project. My wife said me like, you are crazy, like what are you doing? Like you're killing like, you know, relations, like because you're not living with us, you're living with a computer, like something like this. I said like, wait, it will pay off for later, like you know, at someday we will compete with Google. He said like, you are crazy, like but I love you anyway. I stay with you.
You have still the same wife right now?
It's a good
you don't have to answer. You don't have to answer. This is too private. Okay, then go ahead. Okay.
So we have very good relations.
Okay.
So what was next? Next, I built the system 2 years, and it became very, very sophisticated. Honestly, and
what you built?
At some
what
point,
you built?
So we use it inside Elastic now, but people call it backend as a service. Sometimes.
How you got the idea and how you started? What was the first line of code of backend as a service? So, there was the first night. What you did? I mean, how you got the idea that you need something like this, and what you started with? So this is always interesting. What you did the first night.
Look, it was probably or upload or sign in. Something like this.
Yeah, of course.
Probably sign in.
Because you have to. Of course, because you have to test it from day one. Okay. Mm-hmm.
Exactly. Yeah. So we built serverless solution in 2008. 2008. And we started to think about, okay, maybe we need to raise some money for our project and make a commercial stuff. But I did not know English at all at the time. Honestly, I don't know. I did not like it for some reason. So we started to build presentation and visit some events. It was actually some trendy to do like startup at the time. And at some point, one of our co-founders showed up at a specific event, and one of the investors read right word in the name of our presentation.
Okay.
It was cloud.
Of course.
It was cloud. So we figured out we built something like a cloud.
I know what it was. Is like your bio. No, I grew up in Ukraine. There's a lots of clouds. The weather was bad. It's like, hey, cloud, you get the money.
Why I call the cloud? Because the solution Google App Engine was in some way close to what we do. So in some way close to it. Our solution was easier with less things to do, faster, but it was like a cloud.
Was Solaris based with containers, or was it Linux based?
No. It was Java based, but it was already on Linux. Yeah, so
it was Java based. So you okay? And I mean, I cannot. Is it like an application server with shared deployments, or what? What was? I mean.
So it's a stuff that deploys, let's say, framework deploys on top of Tomcat with Spring libraries. Yeah, and it makes you able to use our APIs. So you can just call APIs and interconnect APIs. We also have engine which we called cloud scripting engine.
Wait a second. You say now is this exactly the same what you did 2008? I mean, not exactly the same. It's the same idea.
Look, that principle we did not push that principle to end customers. We rolled it down a little bit because it was too far after we did initial. Let's say, survey, what people like and what they will use. Like we realized that it will be very hard to make a commercial product based on this because companies do not want to look for specific API, even specifically if you are a startup. So nobody knows you, like nobody will write for your API. So it's too early. In 2008, it was really too early. We decided to scale down from backend as a service to platform as a service.
Okay.
But this backend as a service is very actively used inside Elastic. So we use this solution for our own needs. It helps us very much. So this is the reason why we move so fast, because we can build solutions very quickly on backend as a service we built for ourselves.
So what I remember, I actually recorded even a screencast with your software. Is I was able to, to say I would like to have 2 GlassFishes with a nice UI, so a nice user interface, and I said I would like to have a cluster of 2, and I just pushed the wall and it worked. So it seems like there was a big Payara or GlassFish was in your cloud already. So is it? Yeah, but is this where is the GlassFish running in a container or what? What is it?
Yeah. So what happened? Look, after we built this backend as a service. Again, like it's very, you can make an analogy like Lambda together with APIs injected inside, let's say. So, but it's running inside Java Virtual Machine. Anyway, so after we met our investors, we realized they have access, they have containers technology. So they are one of the guys who build containers. And I knew about containers in my previous organization when I was working with Sparc, because I visited event where Sun introduced containers as well. At that time, I did not understand what it means, like, and how it works, but, it sat somewhere in my mind. But after I met the investors, I realized they have containers. I started to play with this solution, and I was very much excited
Yeah.
about elasticity of containers, how flexible they are, so that you can scale them vertically. I was so much excited that we decided again to scale down and move with platform as a service and build container runtimes for developers. So they can go easier with this staging, clustering, reliability, redeployment, and all this complexity, system administration complexity. So yes, this GlassFish and Payara instances, each of them is running inside isolated containers.
Okay, this is what I saw. So interesting. So the first thing what you did, I always actually at that time frame, I always ask myself why Sun is not doing this. Because I don't know whether you remember, there was the Grid project from Sun. This was the first cloud from Sun Microsystems. And for me, it was a way too hard to operate. So you had to zip everything, upload or whatever. And they always had the years of war. So I asked myself, why they just not run whatever server they have? And we can just push this ear to the cloud and this is solved. The APIs are there. And this would be serverless, actually. Because you can push, the war. And you don't care about the server, and you can say, okay, I would like to have a cluster of 2 or 1 or 3 or whatever. I don't care. And you actually implement this as well. And I always ask myself, why no one is doing this, right?
Yeah. I don't know why Sun. Maybe because they made money from hardware.
Yeah,
right?
exactly.
So and it was a conflict of business models.
Yeah.
For them, and it was risky maybe, and they did not take a risk.
But you did it, so that's interesting. And this is why Google App Engine was very similar. They also had, own persistence, but this was not standard. They had their own API. I forgot actually the name. It was JDO based and kind of transactions. This was interesting that you did it.
Yeah.
So what you could deploy WARs to your solution, or what was the packaging? So you could deploy zip or WARs, or what was the idea then?
Inside our
the first solution.
Look, it depends again. If you talk about current situation,
when back then, the historical solution.
Historical, I mean backend as a service, right?
Yeah.
So you deploy, we call them scriptlets, snippets. So it's a part of just code, so like a Lambda code, some small part of the code that do interconnection of API calls.
Yeah, it's Lambda actually.
Yep.
Yeah, and then you scale back and then became, container provider. So now you are similar to, let's say, Linode, right? Something like this. You know Linode?
Yes, I do know Linode. We are not like Linode completely. There is a significant difference. I can tell you what it is. First of all, our business model. We are software vendor. We are not cloud provider.
Okay.
We do not operate data centers at all.
Okay.
So we don't touch data of end customers in the most cases, only if customer asks us. So what we do, we build software for data center operators, for data center managers and owners.
Okay.
They can install our software on top of their infrastructure and convert traditional data center business model to cloud business model.
Okay.
So they can offer platform as a service with our solution. It's a turnkey solution to deliver full life cycle related to cloud business. So end customers will get nice, helpful, and powerful platform as a service. Service providers will get the tools to understand what's going on with this cloud business, like how many users, who is the most active, what exactly they deploy. Is there any fraud actions, alert monitoring system, marketing campaigns, a lot of things around this. It's not really simple one, but it's a turnkey solution. Then we provide second level support to data center providers, and we try to watch quality of our partners around the world. So if a user faces a problem with our partner, we can jump and solve the problem. Specifically, try to figure out why the partner was not able to provide good quality of services.
Okay.
And try to figure out if customer wants to migrate that data to another provider, help with this.
Okay.
And so on. So at the end, we have catalog of our partners around the world, certified partners, that offer Gelastic. And end customers can choose different locations and companies with different jurisdictions. So it's not owned by US-based companies.
Okay.
So if your company is from Switzerland, most likely you want to host data inside Switzerland,
Yeah.
and you want that this data is managed by Swiss company, not US-based company. So this is the case with Gelastic. So we give, first of all, freedom of choice of jurisdictions around the world. The data has sovereignty, so it stays inside country. It's managed by local people. So this is very important today. In the past, it was not so much, but today, like, in the modern world, it's very much important. So there are many different regulations like GDPR, right?
Yeah.
And other countries are adding similar rules.
Yeah, and privacy is really good marketing, I would say. So really, yeah,
exactly.
Okay, I got you. So another question. At one point of time, you worked together with James Gosling, right?
We are still connected very well.
Okay. But he was one, what was it? Chair or was something from Gelastic, right? At the beginning?
He is an independent director. He is still independent director.
Perfect.
So if something happens, we cannot, for example, come to the same page with investors, right? Like, or if there is a big decision we need to take, like he will know about this. I will inform him.
Okay.
And if his opinion, he can tell us, okay, I believe this way is a good way to go.
Very good. Right? So, if I install Gelastic now, I mean, if you can reveal what's behind, is it a Kubernetes, flavored Kubernetes, or is it like what you're doing actually? Why I should choose Gelastic and not, let's say, OpenShift?
Very good. If you have deep pockets, free money,
so you are cheaper?
Yes, exactly, like significantly. So you can get significant cost reduction.
Okay.
So then, look, Kubernetes is a great solution. So no words about this. It's moving forward. Many people adopting it, but still it has some limitations, right? Specifically related to stateful workloads.
Yeah.
We are super cool there. You can migrate all traditional workloads without significant efforts to Gelastic. And we will scale it, if not horizontally, then vertically. So you will get this scalability. Again, it's much easier to do transition from traditional to cloud with Gelastic. So digital transformation gets easier. I would say,
but for me, this was not like a heretical question. It was more like Kubernetes just starts containers, right? So you need something which starts and stops containers. I assume your solution is also container based, and so you need a kind of container starter, and then you get the Kubernetes operator.
We built everything by ourselves. So because we started to build the platform in 2008, if you remember. In 2010, we got first money from investors, and we got access to containers. We built platform as a service from 2010.
Okay. And the containers are still using Docker or OCI, or just the OCI and OCR, I think, is the container runtime. So you are abstracted from the Docker, or you are using the Docker directly?
Our case is the following: as we host multiple heterogeneous applications from different customers on the same hosts on the same physical machines.
Yeah.
Security is super important. We cannot go with default Docker runtime. The best one runtime for us was exactly that our investors was holding. It was Virtuoso. It is Virtuoso, or OpenVZ. People know it, OpenVZ. It's designed for hosting industry. So it was tested during 15 years or 70 years. So it's good enough in terms of security for us. So we can install Gelastic, software stacks inside Virtuoso containers and deploy them on bare metal host machines, and it works great.
Okay.
How we merge this with Docker, but Docker again, Docker got very good traction, and people know Docker, but people don't know about Virtuoso. So we just merged two things. We merged two containers. So now we have the best from the both worlds. You can package in Docker format. You can build with Docker approach. When it's ready, we get this image, and then we convert this to Virtuoso containers.
Okay, so then you answered my question. This is very similar. This is actually whether you are working, via the OCI, because the Docker became standardized and you are no more dependent on Docker. And OpenVZ is an interesting solution. So you are using OpenVZ instead of Docker, but you get the Docker development experience, right? So yeah.
Correct.
That's interesting, but this would answer the question, because Kubernetes would be hard to customize for that. But in my eyes, the operator, if you're building, a more focused solution, in my eyes, it's not that hard, to start and stop containers. And because Kubernetes is a general or generic solution, they have, to think about pluggable operators and pluggable schedulers and thinking about, GPUs and whatever. And you can say, okay, this is our focus, so you can simplify the entire stack and make it more usable or less complex.
Yeah, makes sense. Makes sense. I agree.
Yeah, I just wanted to, because I'm not pro Kubernetes, I just would like to understand what you're actually doing, and now it makes sense. So you're using OpenVZ because of better isolation, and you build your own orchestrator because you can talk directly to the OpenVZ virtual machines, and they can start and stop. And have you looked at something like?
And look about live migration, for example, right?
Yeah.
Live migration. Mm-hmm. Why people do stateless? Did you think about it? Like, why the stateless movement started?
Yeah, because it's easy. Because it's easy. Because they killed and start somewhere else. This is the migration, right?
I can add some little bit to the sentence. Because it's easier for service providers to manage infrastructure.
Yeah, this is exactly like, why no SQL came. Because it was hard to implement SQL on key value stores, right? And then they find out that actually everyone would like to have SQL, and now they change that to not only SQL, and now it's just pointless. But yeah, and as stateless, everyone, this was what I really hated at conferences. Everything has to be stateless, but we have state, Yes. We cannot just. What it means is if I store everything in a database, it becomes simpler. And in my firefighting projects, we never had. Actually, we barely had problems with the application servers. Or I cannot remember that we have any problems with application servers. If we have scaling problems with the database, always database, right?
Exactly. Yeah. So scaling applications is easier. It's easy.
Yeah.
It's not really hard.
And the conference is no stateless workloads. Yeah, okay, fine. But yeah, therefore is the and now Kubernetes remembers. Okay, actually, we would like to have stateful workloads, and now they have stateful sets, and now everything comes afterwards. Yeah.
Look, but they call it stateful. I think they had confusion too.
Yeah. What is stateful? That all the nodes are starting in the right order, right? So this what you get. That the master will state.
Stateful. Look, they don't say stateful for storing data in memory,
no.
Right? They say stateful states save data on some storage, just.
Yeah.
But it's not a stateful container because this container doesn't store anything so why it's a stateful container?
Yeah, what they call it stateful sets in Kubernetes is if you have, for instance, master slave or follow leader solution, politically correct. Mm-hmm. So then with Kubernetes, if you say it's stateful, it will start the master first and then the slave, right? So this is what a little bit, we get more support for stateful applications. Now, okay, but cool. Yeah. What I saw is you also supporting Jakarta EE9. So I was curious to know what your solution has to do with Jakarta E.
We provide runtimes for end customers,
mm-hmm.
right? And Jakarta is standard for runtimes, for such runtimes. We support such runtimes. So we create clustering for some of them.
Which one?
And for GlassFish, for Payara,
mm-hmm.
for Wildfly,
mm-hmm.
I believe. Yeah, for Tomcat and Tommy.
Open Liberty,
Open Liberty, they have a very good solution for Kubernetes. So we decided to go with Open Liberty inside Kubernetes, inside Elastic.
Okay. Okay.
It's possible too. So you can run Kubernetes inside Elastic, and you can enjoy better elasticity at the end. Yeah,
and then you can deploy your scriptlets from 2008 into Open Liberty. Then it's the full circle.
Yeah. Yeah, exactly.
Okay. Have you had the chance to look at Firecracker, for instance, from Amazon? So the new virtual machines, which are they are high isolation, but not as
yeah.
And you like this?
Yeah, I like movement in this direction. So look, we need more projects like this. I really like it there. So we tried to use it.
Mm-hmm.
It does not fit to our platform yet. Does not have enough functionality yet.
Yeah.
But in general, it's a good movement. So more projects we have,
mm-hmm.
better solution and customers will get it there.
Mm-hmm. And what I understood now with the OpenVZ and so forth, is your solution right now still Java-based, or you can just run Java? Or are you using Java inside Jelastic for your own purposes?
We do use Java heavily inside Jelastic.
Wow.
But it's not only Java, of course.
Mm-hmm.
It's not only It's not only Java, it's a set of Python scripts, right? Some bash logic and so on. But the main modules are written in Java.
Okay. And is your solution only, for larger customers, or can developers play with it, or, because it sounds like a nice project?
Look, it's the following. If you're a small guy, I definitely recommend you to go to one of our providers because you will enjoy pay-per-use. So never pay for the limits, pay for only real used resources. And Adam, please remember this, like when this model becomes popular across the world, like, and everyone will offer it, so Gelastic started it. So what we do, like, very important, and actually why virtual containers is important, because they help us to do it. So what we offer, if you go to, let's say today, like to DigitalOcean, right, or to Amazon, and you buy like some instance, 16 gigabyte of RAM, but your application is using only 2 gigabyte of RAM, you overpay for all these unused resources.
Yeah.
I still understand if it happens with virtual machines, because most likely, like, resources allocated to these virtual machines. But now what we see, like, companies started to offer containers. Containers share resources by default with other containers. You don't need to do anything. It's just done by default. But service providers charge you for unused resources. Right? Like, so it's not fair yes, it will generate more money for cloud providers.
Yeah.
But I don't believe it's it's a good business. So there should be better model.
Yeah.
And we offer pay-per-use. So if you don't use resource, you don't pay for it.
Okay.
And it solves very huge problem, which is called right sizing. Imagine you have 100 environments, and per each environment about 10 containers. So you have thousands of containers with different stacks. How you track all these, configurations, like this container need a little bit more RAM, that one little bit less, like to be more efficient. Like it's very hard to fine-tune all these limits. So if you have to pay for the limits, this problem will always exist.
Okay.
If you don't pay, like you just don't care, like you set high limits and that's it. If application needs more resources, it will get. If it's not need, it will not pay for it.
Okay.
So,
but how to get? So do you have some favorite partners, or how to register to your cloud? I mean, what to do? So
easy. You go gelastic.com, you will see sign up, and you will be able to choose a partner, or you go to gelastic.cloud, where is the catalog of partners.
Okay.
And you can choose by location, by quality of services, by quality of infrastructure.
Okay, cool. Thank you. So do you have any other pointers? You have a blog, Twitter, or?
Yeah, follow my Twitter and blog, gelastic.com/blog. We write about interesting things like after clustering, vertical scaling very much. So please follow us, and you can learn more about platform as a service in general.
Oh, perfect. So thank you. And I would really like to re-invite you back and talk a little bit more about what you're doing at weekends, because this is the interesting stuff, what you're hacking at weekends. Then you wanted, to chat with me with kite surfing, because I have no idea how it works, but you can explain me, right?
Kite surfing? Yes, kite surfing.
Yeah, because this is the next time. We have a chat next time. Yeah, I would say January, February.
Sounds good, Adam. Yes, let's do it next time. Yeah. Thank you for your questions. It was very interesting conversation. I enjoyed this very much.
Yeah, thank you.
If any questions happen, just let me know.
Thank you.